trinomials. And a little subheading is factoring. And little subheading under that is kind of special cases. And special case number 1 is what we like to call perfect squares. Wait, yes. Which to me is not really that special. And that simply means this. If I have x plus 6 squared, I'll give you a second to look at that, because I'll tell you what, about 70% of the people look at that and they go, well, the answer to that is x squared plus 36. Was anybody saying that? Anybody jumping on that bandwagon? Be honest with me. Do not try to lie to the teacher. Brooklyn was. She raised her hand. What should the answer to that be, by the way? What is x plus 6 squared?
You have to do another x plus 6 squared, or x plus 6.
Yeah, you need to, if you're going to do this, you need to break it into x plus 6 times x plus 6 and do FOIL, which is actually going to give you x squared plus 12x plus 36. Do you know what I mean? Because this gives me this. 6 times 6 gives me 36. 6x plus another 6x gives me the 12x. And if you look at on your worksheet there are a couple of those. Let's see where they might be. Problem number 7. If you look at problem number 7, where it has x squared plus 2x plus 1. When you break that into two binomials, what do you end up getting? What times what gives you 1? X plus 1 times x plus 1. So you end up with x plus 1 squared. That's really how the real mathematical people want you to write that answer. Now, special case number 2. This one really wasn't a special case, but number 2 looks more like this. It's like problem number 1. When it's actually m squared minus 25. And we did brush upon this before. Okay, one way to think about this is really not a trinomial until you put that little term in there. It should be m squared plus 0m minus 25. In which case, when you break this down, you end up with an m and an m. And what times what gives me negative 25? When added together gives me nothing. It should be pretty simple. Keith Stewart? Positive 5, negative 5. And here is what you're looking for. Okay? This works as long as these things are true. Okay? This must be a perfect square, which means you can take the square root of it. M times m is m squared. This needs to be a perfect square. In other words, 25, you can take the square root of 25, which is your 2 5s. If this was 24, this would not work. You could not factor it. And last but not least, the only way this works is when this is a negative, or a minus sign, I guess you want to say it. Let's just make that a minus. Understand this very clearly, ladies and gentlemen. M squared plus 25 is not factorable. You cannot break that down because there's no way to multiply two numbers together to get a positive 25 and get them to cancel out to give you a 0. Because the only way to get a positive 25 would be both of these to be positive 5, which would give you a plus 10 in the middle, or for them both to be negative 5s, which would give you a minus 10 in the middle. So if you don't see the subtraction sign there, you cannot factor it. So take a look, ladies and gentlemen, on your little sheets there. Which ones of these, which problems, circle right now which ones you think you can factor that are two terms. Let's look at number 8, by the way. Just because. Number 8, 16r squared minus 25. Sorry, 16r squared minus 25. First step, always, 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 don't forget about it. Can I factor some number out of 16 and 25? You can't. Maybe wrong. No number goes besides 1. Second thing, is it subtraction? Yes. Are these both perfect squares? Is there some number times itself that gives you 16r squared? Laney Kavarik, it would be 4. Yeah, you would get 4r times 4r. They're the same thing. One has to be minus, one has to be plus, and then what times what gives you 25? 5 and 5. You will get no middle term because this gives you a plus 20r, and this gives you a minus 20r. So this really should be easy because you should right now be able to tell me the answer to problem number 6. If you look at number 6, 9x squared minus 1. It is subtraction. They're both perfect squares. It follows that same pattern. You end up with... Somebody want to dare to jump on that bandwagon? Delaney Guiney?
3x plus 1, 3x minus 1.
Correct. 3x plus 1 times 3x minus 1. They're both perfect squares. This won't really take you guys will be finished with this before long. And then the last case we have to look at is problems like number 12. 5x squared minus 54xy plus 81y squared. What's different about this that we haven't really come across before? Kate Kunacek? Yeah, you got X's and Y's. You got letters in this thing. We've never had letters in that term before. Don't let it frighten or scare you because it's really done the same way. Let me do a binomial times a binomial. What if I have X plus 2Y times X plus 3Y? Let's do that out in FOIL, and maybe you'll see what happens here. F-O-I-L. The two first terms still give me x squared, correct? The two last terms, 2y times 3y gives me 6y squared. And then what do I get in the middle? Well, x times 3y is 3xy, and 2y times x is 2xy. Add those together, you get 5xy, which is really the same thing you got there. You just need to know that if there's a squared here and a squared there, when you factor it out, okay, you're going to have an x here and an x here and a y there and a y there. That'll give you the y squared at the end. These will give you the xy's that are in the middle. It's done the same exact way, it's just that there's a letter in the second thing. You still need to look, can you take anything out of those? 81, 54, 5? No. So you're left with one being a 5 and one being a 1. And then you try what? What times what gives you 81? Added together gives you negative 54. Remember, whatever you put here gets multiplied by the 5. What is it? You must see it, do you? Negative 9 and positive 9. Does that not work? Well, maybe it doesn't. No. 2 negative 9s, right? What's negative 9y times 5x? Put negative 45xy. What's negative 9y times x? Negative 9xy. You put negative 45 and a negative 9 together, you get negative 54. So this, boys and girls and kids of all ages, is the answer that is going in. And I know you say, hey, let's try one. Go ahead and let's do the very last problem. Number 20. 7x squared plus 67xy minus 30y squared. And I'll make this deal for you, with you, and about you. For every 2 people that get it right, I will take away 1 problem of tomorrow's assignment, as long as you are here in class at this point in time. If you're not in class, volunteer. That's all. Just because you're here. For every 2 people that get it right, I couldn't do every one because then you may not end up with any problems at all. Every 2 people. But you must circle your answer in bold things and put your pencil down so I know that you won't cheat. Some of you do cheat. Just don't know who. 7x squared plus 67x minus 31 squared. This one could be a tough one. A lot of combinations here. Although 7, there's not many combinations with 7. I wonder if this is what she's doing. Pretty good start. Only so many ways to break up 30, by the way. Seems like 31, 3, 10, 5, and 6 would be the next factors. Only choices there. 67 seems to be a pretty high number. Where's yours? No way to get 7x squared is 7x and 1x. Maybe 7 comes from. Those are my squares. I will give you 38 seconds. Usually, if you don't have it by now, staring at it does not make things any better. Put that crossing your eyes and dotting your T's. Which is what this would be, right? Jeez. What is that? Crossing my eyes. Huh? Dot my T's.
You can just, yeah, put 4 T's in.
Oh, dot your I's and cross your T's? Is that what it's supposed to be?
Yeah, because usually dot your T's and cross your I's.
Dot your,
Because usually.
dot your W's and cross your Q's.
What?
Wait, let me see. I gotta look at this again.
Cross your Q's.
You got your
R's. You gotta cross Q's.
Where is it? Point to me, point to me, point to me. Where's it at? Here. Put your pencil down.
I don't know.
Where's it at?
I hope I didn't do the wrong. 7x minus y, x plus 10y. So the plus and minus is over, right?
Yeah, I got this because I checked it and they minus 3, which is
Consideration works. I don't like it down there.
Alright, so, my calculations, 12 people got it right, so we'll subtract whatever 6 problems. Here is the deal, most of you caught on to this, only one way to get 7y squared. First of all, make sure you can't take anything out of there, and you can't. 7y, or 7x, sorry, 7x and x. Your choices here, to get negative 30, make sure you put your y's in there, because that's one way to get y squared. You'll get your x, y middle term, so you got that right there. The way it was this. Some people put 5s and 6s in there. I don't think there's any way to do it with 5 and 6.
No.
5 times 7 is 35. if you add 6 or subtract 6, you're not gonna get 67. Or if you even flip it around, put 6 and 5, it's 42 and 5, you can't get that. So it gotta be the other one, it's gotta be 3 and 10. You know, if you put a 3 here and a 10 there, 3 times 7 is 21 plus 10, you still can't get it. But if you put the 10 over here and the 3 over here, 10 times 7 is 70, and you can get to 67 by subtracting the 3. 67 is positive, so the big number, the 70, has to be positive. So the positive would have to go here, the subtraction would have to go there. So it's 7x minus 3y times x plus 10y. Or you could add the x plus 10 together.
Yeah.
12 would be. So we get to subtract 6 as long as you are here. If you're not here, that doesn't work. What 6 shall we do?
We should do
We
the
can't
hardest
subtract the 6 that.
I don't want to do 17.
Let's not do these ones.
No 17.
Let's just cut out this part. I don't want to do the one. Can we cut 13 through 18 out? Just get those out.
Yeah.
Can we do 13 and 18? 13 through 18?
No, you can not do all the multiples of 3. So no 3, 6, 9, 12. No 3, 6, 9, 12, 13, 18. Yeah, shush. That's 6 problems. But it's you had to write it down. What? Don't do it. No, as long as you're here. If you're not here, then well, I can't change that. Why does this not stop?